Hello everybody. I hope you completed the 10.1, 10.4 review prior to watching this video. I'm going to be going over the textbook problems that I assigned as a review today so that you're prepared for the quiz tomorrow. All the information that is on the quiz we learned in class, but I would like you guys to be aware that we did change the quiz from the normal in-class quiz. It will be a shorter quiz and more manageable at home. Please make sure that you turn it in promptly tomorrow, and that will count as your attendance for the day tomorrow. So right now, what we're going to do is look at our review problems. So let's take a look at the review. The first question in the review stated, if a chord passes through the center of a circle, then it is called a diameter, guys. A diameter is a chord. Diameter is always a chord that goes through the center of the circle, but a chord is not always a diameter. Let's make sure that we remember that information. All right? Number 2, it says, draw and describe an inscribed angle and an intercepted arc. Now, if I drew an inscribed angle, I would want the vertex of my angle to be on the circle. So if I was to draw an inscribed angle, I'd have A, B, C. An angle ABC is an inscribed angle because the vertex is on the circle. And the sides contain 2 chords. All right? And it says we want to know the difference between the angle and its intercepted arc. So if I take a look at this, we're all comfortable that this now is our angle. That's our inscribed angle. But its intercepted arc is the arc in which the inscribed angle cuts. So that means AC is that intercepted arc. Now, what do we know about the relationship there? We know that if we have an inscribed angle, I know that the measure of that inscribed angle, ABC, would have to be equivalent to 1/2 the measure of the intercepted arc, which in this case would be AC. All right? So the angle measurement is 1/2 the intercepted arc. All right, guys? Very good. Now let's take a look at 3. It says, describe how the measure of a central angle of a circle relates to the measure of the minor arc and the measure of the major arc created by the angle. Well, if we had a central angle, so I can draw this here, just so we remember, a central angle, the difference between the inscribed and the central is that the central angle will have a vertex at the center of the circle. So for example, if this is ROS, O is my center. This would be my center. And if I have a central angle, the central angle will equal the intercepted arc. So for example, in this case, the measure of angle ROS would equal the measure of RS. It equals the measure of its intercepted arc. So if you take a look at that, this is ROS, that's my central angle, and this is its intercepted arc right here. Now that's the minor arc. The intercepted arc is the minor arc when I look at that. But they're also asking, how do I find the measure of that major arc? Now remember, a minor arc is less than 180, and a major arc is more than 180. But I need 3 letters in order to name that major arc. So I'm going to go R, and then I'm going to put a T right here, TS. And if I look at that, that major arc would complete the rest of my circle. So if I wanted to find the measure of arc, RTS, that would actually equal 360, because that's the degree measure of the entire circle, minus the measure of that central angle ROS. All right? Just so we make sure we're clear. So we take a look at that, RTS, you know, if we take a look and then we have our ROS, we like to highlight, I like to color coordinate everything, right? And then we have our RS. So we now can find the measurement of our minor arc, which is RS, our major arc, which is RTS, given our central angle measurement. Good. Okay, now let's take a look at our next one. Our next one had some multiple choice here. It said, in examples 4 through 6, match the term with the appropriate segment. Now, if this is the diagram in which they gave me. And the first thing they did is they said tangent segment. And the tangent segment, remember, a tangent segment can only touch the circle at one point. So LK represents a tangent segment. So that means if I looked at that answer in the book, it should have been B, which was labeled KL. B was KL. That was my tangent segment. And remember, a tangent segment can only intersect the circle at exactly one point. Now, a secant segment is a little different. A secant segment would be something that intersects a circle at 2 points. So if I take a look at this, LN, right? LN would be my secant segment. So that is C, LN. So if I looked at that whole thing right here, LN would be my secant segment. Now, external segment. The word external means outside the circle. So when I think of an external segment, it's just the part of the segment that's outside the circle. So in this case, it would have just been LM. So in that case, A, which is LM, would have been my external segment. Because remember, external means outside. All right? Just so we're on the same page there. Okay? Okay, let's move on to number 7 now. In number 7, what they do is they actually give us x, y, and xc. Now, x, y, and xc, they are 2 tangent segments because they both intersect the circle at one point, and they have a common external segment. What we learned when we have 2 tangent segments that meet at a common external segment, that both of those segments are congruent. So I can now put a tick mark to identify that both of these are congruent. Now, if both of those are congruent, what I can then do is set them equal to each other. So I can say 9a squared minus 30 would have to be equivalent to 3a. All right? And then what we do next is we solve for a. Now, because this is a quadratic, we actually have to bring everything to one side and recall our algebra skills. Now, when I bring everything to one side, the first thing I notice is that 9, 3, and 30 are all divisible by 3. So we can divide every term by 3. And then we can factor. And if we factor, we know we factor into 2 binomials. We have to remember our algebra skills now. Now, to get 3a squared, one has to be a 3a and the other has to be an a. I need to multiply to negative 10 and have a combination to negative 1. So if I think about that, hold on.